Yes. All right, so again, basic logarithm property. Here, Kaylee, let me go back. This is just for you. Okay, so derivative of e to the x is e to the x. E is a number in case you forgot like everybody else did. And then to take the derivative of ln x, it's 1 over x. Now, laws of logarithms. Okay, so that means if we're taking the log, ln is the natural log, of something with an exponent, before we take the derivative, this is not the derivative, okay? We can move whatever the exponent is in front and multiply it. Okay, so we were rewriting this as 3 ln x. And now we're going to take the derivative. Right, so it's 1 over x. Okay, but we have the 3, right? So 3 times 1 over x, or just 3 over x.
Oh, you only put the 1 over the x?
Well, then you do 3 times 1 and get 3.
Oh, yeah, okay. Where did ln go?
It's gone. We took the derivative.
Oh, I put 3.1. I did too.
Oh, that's times.
Okay.
Sorry.
That's why I was. When did we take the derivative?
By doing the 1 over x part. Because 1 over x is the derivative of ln x.
Oh, so since that's like basically the function.
Yeah.
Gotcha.
Yes. That wasn't too bad, was it?
No, I actually kind of like that.
Okay.
If it was
Let's end right there so we can all be happy.
x to the 15th, you do the same exact thing.
Mm-hmm.
And
Yes,
doesn't matter what number it is.
correct.
Got it.
All right, now in part B here, we have 2 things, right, that are multiplied together. Does anybody remember how we can separate that into 2 separate logs? No.
Wait, can you repeat your question?
Right, so how do I rewrite this and expand it?
You do ln x squared times.
Nope.
You just make 2 separate equations?
Not times.
So long since I've seen
Got it.
regular-
Plus, good job, right? Multiplication expands out and becomes addition. So we can add the 2 logarithms together. Right, so remember we expanded and condensed ln x squared plus ln e to the x. Is this not ringing a bell?
Nope.
Okay. I might have to find you guys a video to watch for homework.
Isn't this just like normal, like?
No,
Don't you
what?
just combine it?
No, we're,
Or
shh.
foil, I mean.
No,
Not foil.
Wait, is
no, because it's addition now and not multiplication.
No, I mean like to start it.
All right,
Okay,
shh.
but with logarithms.
Guys, there are too many of, yes, with logarithms, if there are 2 things multiplied together, you can split it up and turn it into addition.
So you're just distributing and then adding them together instead of multiplying them?
Yes, but I really hate that description, but yes.
You just say you're just separating it all.
You're just separating
You're
it.
taking your thing that's outside the parentheses and making it put it in.
But you have to turn
Yeah.
it to a plus.
You're just distributing.
No, no, that distribute means multiply. We're adding now.
What if your parentheses and squish?
But the ln and the x squared.
Uh,
And then the ln.
Okay, whatever helps you remember it, just don't let me hear you say that anymore. All right. Right, so then now what else can I do?
You can move the 2
Move the
down.
exponent.
The 2.
And you can move the x in front of the ln, right?
That is correct. Okay, I can do one more thing. Something cancels out. Any thoughts?
The ln?
Which one?
The first one.
Nope.
The
The
second
second
one.
one.
Yes, right? Because it's the natural log of e.
Ah.
So that is
Oh,
1.
yeah.
Oh,
Yeah, guys, there's a lot of rules here we got to remember.
I'm gonna be forgetting names.
Did she say I'll be forgetting?
I'm gonna be forgetting.
I'll be forgetting.
I feel like that needs to go on the board.
Okay, so wait, the ln
We all know KB for
equals what?
Yes, always.
So it is gone.
Yes,
So ln together is 1.
always.
Why don't we put like 1x? Because the 1's still there. You can't
Right.
just decide something's gone.
It's an invisible 1. It's x times 1. So we typically don't write the... Yes. What?
Is
Yes.
there anything that equals 0?
Yes.
Like
I hate this class.
something in particular that I need to watch out?
Huh?
Like what equals 0?
We'll get there.
It's 2 over x.
Who hates my class?
It brings her pain.
Well, to be fair, yeah.
So does your gallbladder, but you can't have surgery to get rid of me.
This probably was all my gallbladder.
Oh, well. Hey, I need mine taken out too.
Wait, that's the
That was DJ. You
No, that's that part. So now we have to do g prime. We have to take the derivative still. We're not done.
Oh, I scrolled on. I have to lasso.
Okay, so then that becomes 2 over x plus 1.
Plus 1.
No, derivative.
I thought it was 2 over 1 plus x.
Over X.
Oh, 2 times 1 plus x is the same as 2 over x.
So where'd your log go?
We took the derivative of it, so it's gone.
X just equals 1.
Alright.
So we chip.
Where did you get 2 over X? From the
2.
From the
One
first-
over-
from
one
the thing
over-
we did in the other box.
Yes.
ln is the same as 1 over x.
All right, not the same as taking the derivative of the ln of x gets rid of it and it becomes 1 over x.
So the derivative of ln is 1 over X.
Yes.
So you can fill in the number that's before your ln for the 1 that's over X.
Exactly. Good job.
You just made
Yeah. So it's basically, it's 2 times 1 over x, so it's 2 over x. Like, it's your number over x every time. And then the derivative of x is 1. Okay?
Alright, we got it.
That's the end. We ready for C?
Let's do D.
I really like these so far.
They're fun.
Don't bring my hopes.
So I have a quick question.
Yes.
For the e there, the e of the x, we didn't. Aren't you supposed to subtract 1 whenever you do the thing where you move it in front?
We didn't do, no, that's not, we're not taking the derivative. That's just a logarithm property where we are allowed to move the exponent in front. Two separate things.
You like work backwards.
All right, so for this one, we don't have to do anything with the ln of x, right? But can we do the power rule on 1 over x the way it is? No.
So do you switch it back to
Yes.
ln X?
Do we have
Nope.
it to negative x?
Is 1 over X?
Change
X
it to negative
to the negative 1. We haven't taken the derivative yet. We can't like underivative yet. We will. That's a whole second half of the year, later half of the year. But we learn how to go backwards.
What's the point of going
put the
backward?
It allows you to find the area under a shape.
I don't care about the area under a shape.
But it like can actually like it can tell you a lot of really important stuff.
area
Yay!
under a shape?
Like area under a curve. It's cool. Okay, whatever. Right now we're talking tangent lines.
Wait, so I can actually
Negative
use this in
in front of
there.
the
Emma's crying, Kaylee, just so you know.
really just laughing in tears.
Okay.
'Cause I'm just like,
All right, so now we've done this. So the derivative of ln x is 1 over x. And then we do the power rule.
Hold on, wait. Give me a second.
Okay, so negative 1, right, goes in front. And then to the x to the negative 2, because we subtract 1.
Okay. Who knew that?
You did know that. See, why are we getting... So then plus x to the negative 2, right, because the negatives become a plus. Okay, and then we rewrite that like this.
I'm not a fan of the power rule.
You really want to do limits with these every time?
So it's 1 over x plus 1 over x squared. Yeah.
Once I get good at these now.
It's again one. Give it another. I feel like by the end of this week, the power rule is going to be your all's best friend.
Well,
Like,
yeah, because we hated the limits at first, but then we got really good at them.
yeah, you guys are going to get good at it. It's going to be okay.
Why?
And Caitlin, you just haven't had as much time as everybody else to get the hang of it. It'll click.
There were tears. It's okay. There were lots of tears. Sitting in that floor right there by her desk for my test. It's okay.
All right, what Isaac?
I figured it out.
Okay,
I'm
my
enjoying
head
this.
hurts.
I know. Probably because you smacked it with a cabinet.
I had a dream last night that I was Dr. Shepard from Grey's Anatomy, and I turned my alarm off this morning because I thought I was him.
Wow.
So let me go back. Oh.
All right, Derek Shepard.
I was.
All right, we ready for D?
Hold on.
That would look
Okay, so if we're taking the log of something multiplied and we can separate that and make an addition, how do you think we can separate? Yes, good job, Caitlin. Right, so the division is going to become a subtraction. So we're going to have ln of the top minus ln of the bottom. Now what?
You can take that little x and
You
move it to
move
the
them?
in front.
Almost. We're not done yet.
You got a x over 1 or 1 over x?
Not yet.
Move the 2 in front of the ln.
No, because it's not an exponent.
Oh, the ex is something. You make the
Hold on,
ex 1?
She
No.
said not yet.
You have to take the x.
You can cancel
And
out.
move
You
it.
can cancel out one of them, can't you?
No.
You gotta take the x on the 3 ln.
We have not fully broken this down yet.
I'm reading. Let me look.
Hold on, let me chill.
Do something with the exponent x.
What?
Yes, but not yet.
Do you put it all over something?
No.
Just wait, I got
Wait,
this.
hold on.
Can I give you a hint?
No. Yes.
That's a yes. If you want.
Where'd my...
Wait, do you put the x that's an exponent in front?
Not yet. Okay, so 2 times e to the x.
Which is just 2ex.
No.
2 over x. 2 over
2
x.
times 1.
We're multiplying so it can become...
Fraction.
No.
2xe.
Addition.
Addition. Thank you. There is
X
hope.
2 plus EX.
Yes, so we have ln 2 plus ln e to the x.
Oh.
Now,
Why?
can we get a...
2ex's.
And then we still have minus. Oh.
So then,
Now
what
we
about the
have
next
ln
part?
to the X and
ln 3 plus x.
Plus ln x. Okay? And then remember that we are distributing that negative
I thought
through.
we weren't allowed to say distribute.
We are in this case because I'm doing distributing. I'm distributing the negative.
It's only okay when she says it.
Because I know how to use the word correctly, unlike Caitlin. I was really aggressive, sorry.
It was.
Kaylee might not be able to focus during this. She's going to laugh too much. All right. Now we can take the derivative.
So we can move the X to the in front of the thing.
Kate was happy for you.
Oh, actually, yes. Kate's right.
Yep.
I'm happy
We need
for
to
her.
kick Kate out of the class.
No.
I'm happy for her.
We're not kicking Kate out.
Good for
Listen,
her.
I just want to know about the most mentally demanding class at the end of the day.
Take that up with Ms. Jones and Mr. Patton.
Take it up with Micah.
Actually, that's valid. Take it up with Micah. I'm going to go ahead and move my X in front here. Just to save me some. He's doing it online, isn't he? He's supposed to be.
He's says about something counting as something.
No,
I
that
wish
is
that I
state
didn't have to
law.
take
You
that
have to have
dumb
personal.
class.
Yeah, he's supposed to be doing it on his
That
own.
is so annoying.
I don't know.
I could be taking
I think
a
he has a
fucking
login.
class.
Kate, I thought you loved personal finance.
I
No.
don't even get to hear it because you guys talk.
Oh yeah, we don't listen to that.
All right, anyway. Okay, so now we're taking the derivative. Okay, so ln of 2. That's just a number, right?
Yes, ma'am.
What's the derivative of a constant number?
That's actually
0.
0.
a letter. That's a letter. That is not a number.
Yeah, it is. If you plug ln2 into the calculator, it's a number. Okay?
Why is it 0?
Because it just is.
It's 0.69.
I thought it was 1. Oh, never mind.
No. All right, remember ln e is 1, so we're just taking the derivative of x, which is 1, minus 0, and then minus 1 over x. So our answer is 1 plus 1 over x.
Oh, I didn't have an x in front of my LE. Wait, what happened?
I moved it in front. I forgot.
Why did our X go away? Because there's X over X is 1.
The derivative of x is just 1. Because it's x to the first.
So ln2 equals 0.
Because it's a
And
constant.
ln
It
x equals 1. And ln 3 equals 0 because there's like the numbers in front of the ln.
Not, it's just because it's a constant.
So if you put that in your calculator, it will give you 0? So
No, if you take the derivative of it,
What's a constant?
If I wrote,
it's a number without a variable. There's no variable there. It's just telling you it's the natural log at 2 or of 2.
if I was to just plug in that to that, would it give me that?
No, because you have to be taking the derivative of it.
Might
Okay,
just
so
be a
wait,
good
quick
class
question.
after all.
ln of E is 1, right?
ln e equals 1, yes, right? So then we just took the derivative of x.
And then X is 1.
Right. All right, let's do another one.
I cannot believe we thought that first quiz was so hard. No, that was a waste of a bad quiz grade. My grade in this class would be fantastic if it wasn't for that quiz.
Had to humble you early. Okay.
So easy though.
All right, so we separate this one, right? ln of 4x cubed plus ln of e to the x. If I talk louder, I can't hear you. So ln 4 plus ln x cubed. All right.
Actually, ask them why it's like not supposed to do that?
Because distribute means you're multiplying. You're not multiplying ln through. Like, ln's not a thing you multiply.
But you're
It's a thing you do.
attaching
No, that doesn't mean you're distributing.
it. Smush.
Okay, I don't know that I agree with that either, but it's not mathematically incorrect, so I can't yell at you.
I'm just writing things down.
Oh,
Is everybody with me?
Yeah, sure.
Okay, so can we derivative? Well, almost. Remember that that is 1.
So then you just have x.
So then when you do f prime, right, and make sure that you guys, like, actually take the time to, like, you're working with this. Now, you need to write this part so you know at what point you're starting to do the derivative. Okay? That is important.
Oh, so this
This
is just getting to
this
the
first
end.
part is just like rearranging your initial function
Why can you get rid of L and E?
because it always equals 1.
Oh, for real?
That's why I drew the little thing with a 1. That way, hopefully you remember.
It's weird.
Okay, so ln of 4, the derivative of that is 0. Derivative of 3 ln x is 3 over x. Derivative of x is 1. So our derivative is 3 over x
So,
plus
like,
1.
every time there's a number in front of it,
The ln, it just goes on top.
it just goes on top of it.
Yes.
Doesn't matter what number.
Nope.
Can there be a decimal in front of it?
Sure.
Okay.
It will happen actually, so yeah, probably.
whoa now.
And your 0 is because there's a 4. After your
What?
It's because it's ln, there's no variable with my ln.
So like there's no x.
Right.
There's no x or no e.
Yes.
But if there's an X, then you put it over X.
An e.
Yes.
would be
How?
It's a number.
Yes.
Okay, no x, y, z, yeah, anything that's not a number. If it's pi, that's fine, right?
What?
Pi would be fine, it's a number, right?
So, L pi is 0.
Yes.
How in the tarnation do you do number F or letter F?
That's a great question. Oh, look, we have pi.
Yeah, I don't
Okay.
like
Well,
pi.
guess what? Pi equals 0.
You just
No, it doesn't. ln of pi equals 0. Okay, the derivative of it. All right, so the first part stays the same. The second part we rewrite as x to the negative 2/3.
What do you have up there? Is that 1? It's a pi. Oh, it's an x. No?
That's x, yeah.
Wait. Okay. never mind.
What's the derivative of e to the x?
ln.
1.
Where's ln?
0.
What's the derivative of e to the x? There doesn't always have to be.
There's not 1.
1 over.
No, e to the x is xe.
She had the eye roll.
That's
Uh-oh.
right.
Pi plus EX.
I thought it was x pi e.
What was the question again? I'll give you the right answer.
What is the derivative of e to the x?
ln e x.
No.
Over x.
What'd you say?
E over x.
No.
X over e.
X over e.
No. Look at the top of the page.
I just
E plus x.
E to the x. It's the same thing. It doesn't change.
I said it doesn't have
You said e over x.
I said it doesn't have 1.
It does. It's just itself. Right? We got to learn how to use our words correctly. No. Okay, so that part, it stays the same. Look at that.
Isn't that crazy?
I don't get paid enough. All right. And then, so this one, let's see, minus negative 2/3 x to the negative 5/3 over 3x to the 5/3.
That's really it.
That's just the breakdown.
No, we're done.
We're done?
Yeah.
Oh, we had a g prime now, okay.
Yeah.
I don't understand primes.
So, ex you just.
Prime means derivative. What?
You just carry the ex on
Yeah.
the whole thing?
Yeah. We love taking the derivative of e to the x because it's easy.
That it looks so much easier than everything. I mean, it looks so.
That makes the most sense.
It makes the most sense out of the rest of it.
It's because you guys forgot all your logarithm rules.
What year was that? First
Algebra 2.
That was like
10.
That was
10.
Okay, we're getting into the back area.
Algebra 2.
Oh. I don't remember 10th grade.
Algebra blank.
All right, we're at a good. No, we're not. We can do more.
Why are we stopping?
We got 5 minutes.
Let's keep rolling.
Or was that the year you got extensions?
Wait, we can do our calculator roll call.
Oh, yay! Homework.
Oh, you kidding me?
You are not gonna do that on a Monday. You are.
This is water!
Ah.
We have a 19-page physics quiz! No, that's gonna take days.
That's why you have days.
Research paper 2 instead.
Okay.
Y equals 14.
First of all,
Y equals
I wasn't
0.
going to make you do it tonight, but with that reaction, maybe I should.
First of all, it is
Number
her
1 is
problem.
0, ain't it?
No, it's not, but it's my problem.
Number 1 is 0, ain't it?
Yes.
Good job, Dylan.
Oh, let me go fill that in.
All right.
0.
Oh, we already did some of this.
I feel like we could do it.
The
Let's.
first one.
All right. Let's split it in half. Let's do 1 through 7 tonight.
Deal.
Okay.
I'll shake hands on it.
I can do that.
So 1 through 7.
I do the first one.
It's 0.
I mean, yeah, no.
That was aggressive, sorry.